In Unit 16, we're going to be talking about similarity and congruency and scale. In Unit 16, Part 1, we're talking about similar and congruent figures. So a couple definitions for you. First off, similar figures have the same shape, but not necessarily the same size. So same shape, not the same size. And then when we're talking about similar figures, the corresponding parts are the sides or angles that have the same relative position. So if you look at this little explanation that I printed out of the book, it says properties of similar figures. So it says the first thing is that corresponding angles of similar figures are congruent. So the angles that match up are congruent, which basically means equal, just when we're talking about measurement. And then the ratios of the lengths of the corresponding sides of similar figures are equal. So for the angles, they're just actually equal, it's actually congruent. For corresponding sides, it's the ratios that are equal. So what we're going to look at first is identifying corresponding parts of similar figures. So it says given triangle JKL is similar. So this little symbol right here means similar to triangle PQR. Name the corresponding angles and corresponding sides. So what I want you to notice is that the order that the letters go, so like JKL, that matches up with PQR. So when we're talking about angles, that means that angle J matches up with angle P, because they're both the first letter. So angle K would then match up with angle Q, and angle L would correspond with angle R. So with the angles that match up, the sign I put in between them, which is this equal sign, and then with a similar sign on top of it, is the sign for congruency. So I'm saying that angle J is congruent to angle P, angle K is congruent to angle Q, and angle L is congruent to angle R. Now if you look at the drawings, they don't really match up that way, but if you were to flip this triangle so that it looks like the other one, then you would have P in the same spot as J, R in the same spot as L, and then Q in the same spot as K. So those are our angles that are corresponding, and we say that those are congruent. For the sides, and please pay attention to how I write this. So again, the letters match up. So side JK, and I write JK with a line over it, because the line segment, it doesn't go on forever, is going to match up with side PQ. So J and K are the first two letters of the first triangle, P and Q are the first two letters of the second triangle. So they match up. So that means that KL will then match up with QR, and LJ will match up with RQ. So those are our corresponding angles and our corresponding sides. If you notice, for the sides, I just put a dash, because they're not equal to each other, they're not congruent. The ratios are just similar, so I can't do anything besides label them like that. Now, you need to make sure you notice this and write it down exactly how it is, because that's exactly how I want it to be when you do the work. So the next thing we're going to look at is finding the ratio of corresponding sides. So it says the figures are similar. Find the ratio of the length of the corresponding sides of figure A to figure B. So the first thing that you need to make note of is that we're going from figure A to figure B. So all we need to do is write a ratio or a fraction that compares one side on A with the side it goes with on B. So let's say I want to use this side BC. So I know that BC, ABCD, is going to match up with JKLM. So that means it's going to match up with KL. So I can do BC over KL, because those are corresponding sides. So that would be 9 over 12, which I could just reduce to 3 over 4. Let's say I wanted to do CD. So CD is the third and fourth letter, so I need to match it up with LM, which are the third and fourth letter. So I would have 15 over, I know this is 20 because it's a rectangle, 15 over 20, which would also reduce to 3 over 4. So as long as you match up the sides correctly, they should be the same amount when you reduce them. So I'm going to leave number 2 for you guys to try. So pick a side from figure A and put it over the side that corresponds with figure B, and then just reduce it. On the back side, it says finding measures of congruent figures. So We said that similar figures have the same shape, but not necessarily the same size. Congruent figures are the same shape and the same size. Okay, so these are exactly the same figures. Now, there's a couple things you need to know there. The angles are going to be congruent, and the side lengths are going to be equal because they're the exact same figure. So for number one, or sorry, for these questions, it says given EFGH is congruent to PQRS, find the indicated measure. So the angle P is what we want to find, which is this angle right here. So angle P would match up with angle E, so we know that's going to be 98 degrees. We want to find angle F, which corresponds to angle Q, so that's going to be 126 degrees, again because they're congruent. We want to find RQ, which matches up with FG, so that's going to be 8 centimeters. And then we want to find EF, which matches up to QP, so that's going to be, actually PQ, sorry, so that's going to be 15 centimeters. Again, when you have congruent figures, the angles and the sides are exactly the same. All right, moving on, we have a work problem here. It says a rectangular banquet room has a length of 36 meters and a width of 24 meters. The rectangular dance floor in the middle of the banquet room has a length of 16 meters and a width of 10 meters. Is the dance floor similar to the banquet room? Well, the first thing we want to do is draw both of these. So I'm going to start with the banquet room. So that's got a length of 36 and a width of 24. Inside of it is a dance floor. The dance floor is 16 by 10. So the question is the dance floor similar to the banquet room? So what we want to do is see if the ratios of the sides are the same. So I can start by doing 24, which is the banquet room, over 10. Okay, so that's the width of the banquet room over the width of the dance floor. And then I can also do the length of the banquet room, which is 36, over the length of the dance floor, which is 16. Now, if these are similar, that means that when I reduce them, I should get the same thing. So this is going to reduce to 12 over 5. And this is going to reduce to, that's going to reduce to 9 over 4. Okay, so they do not reduce to the same thing, so they're not going to be similar. If I wanted, I could also do a proportion to check and see. All right, a couple review problems for you on the bottom. Make sure you fill in any gaps and ask me any questions you have.